Okay, welcome back to the final segment here. I just got thinking after I left you off there um, with that last example. So some examples that may be other factors to investigate. So if you're looking at it from a project perspective, and you at first thought it was temperature and yield that was the relationship, what else might play a factor? So from an agricultural perspective, it could have been soil conditions. So I just want to give you a couple of examples of what I would expect. Rainfall, so the amount of moisture available, compaction, okay, if the conditions aren't ideal for growing. So you can list a bunch of examples as well, because I like, this is what I really want to see, is that outside the box thinking, okay, if these two aren't the main relationship, what could be influencing the results? All right, last example. So the following information was collected by a series of tests on popular cars. Answer the following. So we have a series of cars here, and again, I've entered the data into the spreadsheet, so it's example number 2. Same thing, determine the correlation, so it's exactly as what we had done in the previous example. So hitting example 2 tab, here's my data. Okay. Now, this one's a little bit more challenging because it's got 3 columns. I don't want 3 sets of data plotted here. What I want to know is there a relationship between power and fuel used? Okay, this just tells you where we collected the data from. This is what I want to see if there's a relationship with. So again, you highlight your data, you go to insert, you go to a chart. Again, it never goes to scatter plot. So you got to hit more, scatter, scatter. Now we can customize, and this is where you put your information in. So power, oops, what happened there? Power versus fuel consumption. So nice nowadays, everything's right there for you. Horizontal axes. So on the horizontal, I have horsepower. Enter. The vertical axes, I have fuel consumption. All right, look at that. It's a perfect chart already. Everything's there. It starts at 0, which is where I want, 0 to 300, and then on the vertical axes, I really want it to start at 0, 0. It doesn't have to, but I don't know. It gives me an idea of whether it's partial or direct variation. I just like having that. I like seeing 0, 0. Okay. Moving down, now that I've done my rant there, you can put your grid lines on. So I want to go horizontal. Same thing. Let's go to, there we are. Okay, scrolling down, scrolling down. All right, so and I'd like to do this kind of before I do everything. This looks to be a stronger relationship because that corridor, I'm assuming my line of best fit's going to come through here somewhere. Those data points seem a little tighter. So I'm going to say for A part, based on what I see, based on the graph. So for A, and you don't have to, but it kind of double checks the process, make sure you've entered everything in right. So based on the graph, I would predict I'll go out and limb and say a strong positive correlation. All right, that's purely observational. So now that you've made that observation, you go back to your spreadsheet, and now you can put the trend line in, and you know what? I won't know whether you do the trend line first or before or after anyway. So I insert the trend line, and I do see that relationship. It looks pretty much where I kind of predicted. You want to click your R value, and it shows up there. So remember, this is R squared, and I'll talk about in the next video what R squared means, but we want R, okay? So I can hit insert. We now have a nice graph. If you want to insert it into a project, the R value is clearly shown. So I'm going to do it here because I don't want to get a calculator out. Looks like 0.66 repeated. So my R value is equal to the square root, all right, of that value. And lo and behold, 0.82, so it's well into the strong range. So going back for a write-up, I can make my conclusions, kind of line that up. So for B, based on the results, there is a strong relationship between the variables as the correlation coefficient is 0.82. Okay, so now you have your evidence to show what's involved there. All right. And then to finish that off, question C, what conclusions can be drawn? All right. So there is definitely a partial, strong, positive relationship. Oops, positive relationship between power and fuel consumption. And there could be other factors because it's not perfect. So I'm going to say because the model is not perfect, there still may be some other variables influencing the relationship. So for example, so what could we have? Well, it could be driver, could be a factor. So if you have different drivers, that could influence the results. Type of fuel used. All right. If we were talking about, got to be careful because Canadian fuel has different standards than U.S. fuel. So there might be, if you're taking the results across the border, that could affect it. Weight difference, because we will have mid-sized sedans that have different masses based on engine size or materials used. And the temperature. If you are maybe doing, some of the vehicles were tested at 5 degrees outside temperature versus 35, it also could influence it as well. So there are a couple factors in there. You can see that the spreadsheet program is fairly simple. It's repetitive. It's the same thing over again. Please make sure you don't forget to take the square root of r squared, because that's all that the graph will spit out is r squared. We just want r when we are looking at the linear relationships. All right. If any questions, make sure you ask next day. And other than that, good luck, and we'll see you tomorrow.